Um, so this slide gives an overview of how this talk is structured. The first thing is to give some context as to how and why I participate at IETF, so that the rest of the talk is hopefully easier to understand. Next will be some brief comments on how I got involved in IETF initially. I'll talk through the standards development process briefly, and then some examples of drafts that I was involved with that didn't progress to RFC, and then some that did progress to RFC. And after that, I'll talk a bit about what I see as the benefits of participating, some considerations before submitting a draft, and then some suggestions for making the most of participating if you're minded to do that. So I work at a company called APIC, which stands for the Asia Pacific Network Information Center. And this organization is the Regional Internet Registry, or RIR, for the Asia Pacific. And its primary job is to distribute IP addresses and autonomous system numbers, or ASNs, to network operators and other organizations within the region. And APIC in turn receives large blocks of those numbers from IAM, who also distributes them to the other RIRs. Aside from that principal job, APIC also maintains various technical services that are strongly intertwined with the resource distribution function. It provides training for network operators, both by an online academy and through in-person training. And APIC is very much a community-based organization, so there's a policy development from the community is a very strong aspect of what it does. So APIC, the Secretariat, the sort of paid employees, help to coordinate that policy development via meetings and so on. So my role at APIC is as the registry product manager, and my main responsibility is application development and maintenance for the services that are on the site. So the first one is the core registry, and this is kind of like the Internet Number Resource Ledger. So it records who has what, when they got the addresses, the delegations, transfers between account holders, reclamation of resources when account holders no longer need them, and all the policy enforcement and constraints that go into those sorts of functions. The second service is WHOIS, and the main job of WHOIS is allowing end users to take an address and see what organization controls that address. It has other supporting functionality as well, though, and the main one is called the Internet Routing Registry, or IRR, which allows account holders to make declarations related to the routing of their addresses. So the main thing that account holders can do there is create what's called a route object, which allows them to say that a given ASN is permitted to advertise some or all of the account holder's address space. The third service is the Registration Data Access Protocol, or RI. This is a test protocol to WHOIS, so it's kind of like a modernization of WHOIS, which is a very simple text-based protocol from a very long time ago. RDAP is based on, or builds on HTTP, which means it gets things like first-class redirects, built-in support for multilingual data, and so on. And RDAP also defines a common schema that can be used by the RIRs as well as name registries, so domain name operators. And that means it's a much better situation than with WHOIS, where different WHOIS servers can use entirely different data formats and so on. The fourth service is the Resource Public Key Infrastructure, or RPCAP. This is a PKI where each RIR operates as a trust anchor, issuing resource certificates, so certificates that contain details about IP addresses and ASNs to its account holders. And the account holders can then use those certificates to issue objects related to those addresses. Today, the most commonly issued object is the Route Origin Authorization, or ROA, and that works similarly to the route object in IRR. where an address holder can make a declaration that a given ASN, again, can advertise its address space. And finally, there's reverse DNS. And this is the DNS function that links an IP address to its domain name. So, like the reverse of an A record or a quad A record. And this is used for diagnostic purposes, as well as for confirming that the intent of the address holder is the same as the intent of the relevant domain name holder. So, really the next question is, why is APNIC interested in what happens at IETF? Aside from the core registry, each service managed by the registry team is based on protocols defined in IETF RFCs. And strictly speaking, that's going to be true for lots of different organizations that operate internet-based services. Like pretty much everybody depends on HTTP or DNS and so on. The difference for APNIC is that the protocols, the services that we have with IETF protocols are almost like application layer protocols rather than just substrates. So it's important for us to be across what's happening with those protocols. We want them to remain stable and functional, and they're also quite actively developed, particularly RPKI and other, though we do see occasional things for the other services. But putting aside the registry service provision side of things, there's also the fact that the IETF is responsible for technical aspects of how IP addresses and ASNs are used, and that can affect address policy and so on. So a recent example here is that Android made a change to how the operating system gets IPv6 addresses in supporting what's called DHCP-v6 prefix delegation as an alternative to SLAC. And there was a question, I think, relatively quickly resolved, but still, about whether the idea of delegating a prefix to a user who's connected to your Wi-Fi network or similar had some sort of implication as far as the RIR policy goes, particularly in this case with the European RIR, which is called BRIDE. But even putting that to one side, with something like this, with prefix delegation, a handset, instead of picking a set of /128 as an individual IPv6 addresses, it instead gets an entire /64. So if you have, from an address planning perspective, things become very different. And that's the sort of thing that is useful to know from a policy perspective, and also useful from something we might want to alert our members to or our community to as well. Another related topic is Class C address space. This is IPv4 address space that was set aside for future use when the IPv4 space was first being set up. So the address range is 243/4. And that address space even today is still reserved for future use with no actual use in practice. But we do see drafts occasionally asking for that space to be turned over to private unicast use, so similar to ranges like 10/8, and even somewhat more ambitiously for it to become global unicast space, so that the RIRs could simply delegate. And then somewhat more speculatively, there's this idea of IP administration on other planets, which is active, or IP use on other planets is active work at the IETF, but IP administration is something that the RIRs would want to keep on top of in terms of how does that work on the marine lines in the event that that ends up in production. So those are some examples of how the technical side of things can affect the administrative side of things. Okay, so now that we've seen how IETF and APNIC interrelate, we can talk a little bit about how I participate at IETF. So unsurprisingly, RPKI and other are the most actively developed groups. So most of my work is focused on those areas. And the working groups for those services are the CyberOps and Regex working groups. The goal of APNIC's participation is to make sure that these services remain stable and functional. So this is about reviewing proposals, making sure they're not going to break anything, cause any harm, cause any APNIC specific harm, and so on. We do, though, occasionally propose our own fixes and documents, or new features and things like that. Particularly with RDAP, the sort of general RIR interest in making RDAP a replacement service for Whois, putting aside the question of Whois deprecation. So that's an area where we have pushed things forward in the past. An important aspect of how APU can mark participation is that publishing specifications is not a goal of itself. We don't have a KPI or some sort of measurable outcome around getting RFCs done. And in particular, it can be quite useful to actually dissuade people from doing documents if they're going to cause problems. It's kind of hard to demonstrate that in a measurable way, but okay, so that sets the context, but I think it's worth highlighting just a few points to further couch the rest of this talk. The first one is that I'm only a participant at IETF. I don't have experience in the various administrative roles, like, for example, working group chair or area director. Not all IETF work has the same level of criticality. So a recent example that illustrates this point is that there's a new DNS record being worked on called DELEG, which is going to cover how zone delegations work. And it's a really significant change to how that functions at the moment. And there's a lot of active development of that, fairly contentious discussions at times, and so on. And when you compare that with something which is more in the nature of maintenance, then it's just different types of discussions, different levels of contention, and so on. The third point is that different working groups work differently. There are common parameters, obviously, for all of the working groups at IETF, but there are still quite significant differences. So an example is some working groups might require 2 implementations before a document moves out of the working group. Some working groups might have hundreds of participants and some might have 10. So the dynamics of the different groups can be quite different as a result of those aspects and also the work that they do. And finally, it's an obvious point, but different standards development organizations work differently. And the only one I have experience with is IETF. And at least anecdotally, based on what I've read, IETF, for better or worse, has a fairly unique approach to this sort of thing. Okay, so the next thing I have to talk about is my initial involvement with IETF. So my first meeting was IETF 87 in July 2013. And this came about because there was joint RIR interest in getting developers together to talk about the services that we all had to do our own implementations on. And in particular, to get some RPKI interoperability testing done. This was with a view to some changes that didn't end up happening around trust anchor management and transfers, but was obviously enough still useful to have that testing to make sure that all of our services were working per the specifications and that we all had a good common understanding of how they were supposed to work. And RDAP was also in development at this point in the early stages, so there were various discussions about that as well, and also interoperability testing. And for the next few years, I had sort of draft review tasks and implementation and interoperability work. The implementations, though, for the most part, were just proofs of concept. So really quick things that were hacked together in order to give feedback on a document, not so much ready for production. Okay, so next up is standards development proper. So this slide has a really quick overview of the standards development process at IETF. So the first step is to write the actual draft, and there are lots of tutorials about this on the internet, and obviously plenty of prior art in terms of existing RFCs and so on. So once it's written, it's submitted to the IETF's user portal known as the data tracker, and anybody can register for access to the data tracker and submit a draft without there being any approval step or anything like that.
Then after the draft is available, the next step is to post it to a working group and to ask people to look at it. Then if the feedback is good, you would typically request adoption by the working group. And that's a formal process where the participants indicate whether they think the working group should work on the draft and push it along. Then if it's adopted, then work happens within the working group over a period of time. And then once the authors consider the document to be done, they request a working group last call. And that's another formal process where working group participants are asked whether they think the document is done or if they have any comments on it. Assuming that is successful, then the document goes to be reviewed by the area director, which is an administrative role that looks after a set of working groups that have some sort of commonality among them. Once the area director is happy, then IETF last call happens. And there's a mailing list that people can subscribe to get notifications of IETF last calls, so it's like a way of keeping across all of the documents that are progressing if you have some sort of interest in that. And there's also the directorate reviews, and the directorates are groups that look after a specific area of functionality. So for example, there's a DNS directorate, and they will look at documents that have some sort of DNS aspect to them to ensure that they make sense and aren't doing anything out of the ordinary or whatever. So then if you get past all those reviews, then the last technical step is review by the Internet Engineering Steering Group, or IESG. And this is a board that comprises all of the area directors. And then if they're happy, then it proceeds to editing, which the speed of editing is kind of a function of how much work they have and so on. So that can vary quite a lot. But once editing is complete, then the draft gets published as an RFC, and that's the end of the process. So to give some real examples of how this process works, I'll start off with some ideas that didn't make it very far. Okay, so the first example is a draft called RDAP history. Core RDAP, like with WHOIS, defines endpoints and response formats for the current state of records. So if you want to find out who currently holds an address, then WHOIS and RDAP support that. But it doesn't support getting the history of an address, so who had it previously, or for transfers and things like that. And this is a function that's become increasingly more relevant over time because it's useful for things like IP reputation calculation, determining provenance for transfers, investigating misuse, and so on. So APNIC wrote a draft, implemented it. It's still available today in APNIC's RDAP server. And then we thought it might be worth taking to IETF in case other people were interested as well. However, there was very little interest from the working group when we presented it. Although we don't have definitive answers as to why, we think it's probable that there are two major reasons. The first one is it's not really relevant in the domain name space. Probably most people are aware that if you query for WHOIS information for a domain name, you pretty much always will get privacy protected records rather than actual records about who has the address. And that contrasts very strongly with how things work with the RIRs, where the default is much more to make that data public. So this sort of thing, while useful for RIRs, is not so useful for name registries and registrars. But maybe more specifically, or really more pressingly, there's the fact that history brings in a whole lot of privacy type considerations. So if you have something like the GDPR's right to be forgotten, then providing historical data can have implications for that. And you might have to have processes for excising data when people request that. Whereas if you just provide current state, you don't have to worry about that at all. So we think those were the reasons that this perhaps wasn't very useful in a more general sense. Like a lot of documents that don't progress, I think that this illustrates how you can have something that's implementable, technically sound, and so on. But if it doesn't actually have real practical worth for multiple working group participants, then it's going to be tough to get it adopted and pushed through. Okay, next example is a draft called RDAP mirroring. So at APNIC, we deployed RDAP in production in 2015. Particularly its functionality around multilingual data we were really enthusiastic about, because there are national internet registries, or NIRs, in the APNIC region who have local language WHOIS servers, and we weren't able to make that data available via the WHOIS protocol because it doesn't have support for communicating data in different scripts. So, for example, Chinese or Japanese. And the other thing we were concerned about or had an interest in was avoiding proliferation of RDAP servers, because we'd seen lots of problems with proliferation of RPKI servers in the region. Whereas if we'd have been able to consolidate some of those RPKI servers with APNIC, it would have helped us to be able to maintain things much more easily, to upgrade things, to make sure that services were appropriately provisioned and so on. So we wrote this draft in an effort to hopefully ease the adoption requirements for NIRs to make use of RDAP. So instead of having their own RDAP server, they could instead have an RDAP mirroring server, and we would be able to replicate their RDAP server to APNIC. So that means that they'd only have one client for a server, rather than have to worry about potentially thousands or tens of thousands of clients from all over the planet. So from a provisioning perspective, it's a much lighter burden. And they could even potentially just give us like bulk data using the formats that were defined in this document. But as with history, there wasn't much interest from the working group in standardizing this further. So similarly for domain names, they didn't really have a use case for this. If anything, they had a strong interest in mediating as closely as possible access to their data rather than replicating it and distributing it. And even for the other RIRs, the only other RIR that has national internet registries is LACNIC, the South American registry. And apart from the fact that they have fewer NIRs than APNIC does, they also all share a common character set. So that aspect of RDAP was not such a motivating factor for them.
And finally, we have a draft called RDAP JCARD protocol. So RDAP uses a format called JCARD, which is a JSON encoding of the bcard format that's commonly supported in email clients and so on for context. And there was some criticism over time from implementers that JCARD was kind of awkward to work with, particularly statically typed languages, because of some interesting ways in which it was structured. And the other consideration, the other problem with JCARD was that bcard is very has a large surface area as far as features are concerned. And having to support all of those in an RDAP client, because you don't know what you're going to get from the server, can be a difficult proposition. So these people came up with a draft for a replacement format called JS Contact. And they then wanted to transition RDAP to making use of JS Contact. But from APNIC's perspective, we didn't really want this to happen, because we had this existing investment in JCARD due to deploying RDAP, and we'd also done a lot of publicizing this to the NIRs with the view to this multilingual data aspect. And we really didn't want to have to go back and say, oh, please put any of your work here on hold while JS Contact gets sorted out. So even though we couldn't change the structure of JCARD, or at least not in a backwards compatible way, we were able to write this draft as a profile to decrease the surface area that clients have to support. And we hoped that that would be enough to push JS Contact off a little bit. Again, not much working group interest here. There seems to be a general consensus that JS Contact was a good idea, but there were at least some other participants who shared our concerns around transitioning from JCARD to JS Contact. And just as a side note, RDAP still uses JCARD today, so getting JS Contact into RDAP remains a work in progress. Okay, so some more successful examples. The first one is a document called RPKI Assigned Checklists, which ended up published as RFC 9323. So RPKI has this idea of the signed object, and this is a way of allowing the user to link information to an address. And an example of, or really the principal example of a signed object is the role that was mentioned earlier, the route origin authorization. But from an early stage, there was this idea that maybe it would be good to have a more generic signature object for when you just want to sign some arbitrary file and give it to someone to verify manually. And that's what this document is about. So it was initiated by Yossino's of Denov Fastly, the CDN company. It was based on an earlier draft from APIC and NLNetApp staff that had actually been adopted by the working group. But York thought that document was much too complicated, and so he proposed this alternative document, which was much simpler. And consensus, or rather, the working group quickly swung around in favor of this document instead of the other one. So I implemented a proof of concept and gave them some feedback, and they then invited me to be a co-author on that document. And the process from there was pretty straightforward. They had working group support. It's not, there was nothing particularly contentious about how the document worked. And yeah, so not too long after that it was done. And that service is currently available for APIC account holders as well. Next is a document called RPKI Trust Anchor Keys, which was eventually published as RFC 9691. And this was about supporting an RPKI Trust Anchor transitioning from one key to another. So it's supporting key rollover for RPKI Trust Anchors. This was started by other RL staff. As with RSCs, I did some implementation and review work, and that led to getting co-authorship. As far as the standardization process here is concerned, there are a few things that stand out. Even by IETF standards, this document was in development for a really long time. That's partly because it's about addressing long-term problems, so it wasn't like the RRs had a really strong interest in getting this done as soon as possible. But it's also partly because there was lots of feedback over the time in the group, and it really changed quite a lot over the course of its time in the group. Sometimes documents will go in to a working group and only change a little bit before they're finished off. But this one is much more up the other end, where the document was almost like an in-principle idea. That's then refined quite extensively within the group. Some of the feedback was very direct, which IETF has a bit of a reputation for, but it was all in good faith and, again, really helpful in making the document better. Another thing is that the final IESG review is sometimes a bit of a formality, as in you get some comments, but they don't cause any changes to the document. In this case, the changes actually led to quite a number of, or rather, comments led to quite a number of changes that again, really helps the document to become much clearer and easy to understand. And the last point I want to make here is that when you have a document that's in development for this long, it really highlights the value of how much archival material there is available on the IETF site. You can watch the presentations, you can listen to the meeting sessions, you can look at the chat logs where people were instant messaging while the meetings were happening. And of course, there's all the mailing list history as well. So that can be useful if maybe the document is unclear in some respects as far as its implementation goes, or if you have an interest in seeing how something like this has progressed over time. And the last example is a draft called RDAP GeoFeedNets, which eventually became RFC 9877. So compared with the two previous drafts, this one was fairly straightforward. GeoFeed files, or rather the GeoFeed file format, is used to link addresses to geographical locations. And it's very extensively used by organisations that care about that sort of information. So Maximind is maybe the example that springs to mind, I suppose. Links to geofeed files have been supporting Nuix directly for quite a long time, but not in RDAP, and that's what this work was set up to address. ARIN, the North American registry, is probably the area that's most interested in getting RDAP getting RDAP to the state where it's a replacement for WHOIS. So they started this work and invited me to co-author at the beginning of the process, basically due to previous work we've done together on RDAP. From a standardization perspective, I think there were 2 points to note here. The first one is that RDAP has this concept of non-RFC extensions. So you can write a draft and then publish it on your own website somewhere, and then ask IONA to add it to the registry of RDAP extensions. And it will then get reviewed from people who are very familiar with RDAP, but it's nothing like the process required to take a draft all the way through to RFC. For myself, when we were initially discussing this, I thought using the extension process was definitely the way to go, because the document was very simple. I just didn't see how it would change much by going through the ATF process, and of course it takes time and so on. But there was a surprising amount of discussion that happened, and the document changed quite a lot as part of the ITF process and was improved as a result of that. So even things that maybe don't look like they'll be helped by this process can end up changing quite a bit. And as far as reasons for adopting are concerned, because this perhaps doesn't look too different from some of those documents earlier on that weren't adopted, it's not that clear to me why name operators demonstrate interest in this work. If I had to guess, I'd say it's because they also have an interest in seeing RDAP get further adopted, and also the fact that the document was fairly simple compared with some of those earlier things I talked about.
Okay, so now that we've gone through some documents, I'd like to talk a little bit about the benefits of participating. So the first thing is that you get to debate the various aspects of your documents with lots of different people. Before I was participating in IETF, most of my technical discussion happened within APNIC. Once I got to IETF, you suddenly have to deal with people who have very different interests from yours and your organizations, who operate in very different regulatory environments, market environments. APNIC is a quasi-monopoly, so it's very different from like a registrar who operates everywhere and competitively, or more competitively at any rate. So this is all really useful from a sort of sharpening debate, discussion skills, trying to build consensus by thinking harder about where people are coming from, what they're trying to achieve, et cetera, et cetera. And that's true. I mean, those examples are for RDAP, but it's equally true in the RPKI context, where you have network operators, research organizations, some end users, open source developers, et cetera, all with perhaps the common broader goal of making RPKI work nicely, but different other considerations that need to be taken into account. The second benefit, which relates to the previous point, is that IETF has a kind of reputation for very blunt and direct feedback. I think that's probably fair to say, even though it maybe seems to be less so today than it was previously. But at least in my own experience, the feedback is always constructive, and it's always in good faith, and it's always worth listening to. So even though it can be a little bit abrasive at times, it's mostly all in service of making the document good, and is really valuable in that respect. The third benefit, which I don't see talked about too much, is the fact that as your document progresses through this process, you'll get reviews from people who are incrementally less familiar with the subject area. So you start off with working group participants, and they'll know quite a lot about what you're doing. And then you move to the area director, who knows a little bit less. And then you move to DNS directorate, or not DNS directorate. Then you move to the directorates, and they will typically know a little bit less again. And then finally, you end up at the IESG, where people might have no familiarity with the work that you're doing. But those people are still going to be quite technically competent, generally quite experienced. And the comments that they make as people who are unfamiliar with your work can be really helpful from a usability and comprehensibility standpoint, in terms of making the document less maybe intimidating or unclear to people who aren't familiar with what you do. And the last point is that while RFCs aren't always perfect, it is an indicator that there's been substantial review of the work, and that in most cases, at least, the actual underlying idea is implementable. So there is a sense in which it's probably easier to get somebody to look at an RFC and implement it than with the specification, which is self-published or managed in some sort of ad hoc way compared with this. Next, I'll just talk briefly about some considerations before submitting a draft to a working group. Related to the previous point from the other side, you can always write a usable protocol and potentially get broad adoption without going through the IETF. There are lots of examples of this, but I think really the key one is WireGuard, which is very extensively used for VPNs, but doesn't have an IRC, even though it might look like the sort of thing that should have one. The second consideration is that the time requirements for taking something through a working group and all the way to an IRC are generally substantial and very hard to estimate, both as to how much time is required and when it will be required, because there's no real way to require people to look at your document or review it, particularly at the editing stage. The amount of time that might be required for that is open-ended. You might have a very short process or a very long process. So these are things that might make working within the IETF difficult for some people. The next point is that the process is highly contingent, particularly at the working group adoption and working group last call stages. So making a big upfront investment in a document and implementation work on the assumption that it will sail through the IETF process is generally not a good bet. And finally, being an active participant in a group first before submitting a document is helpful. Probably increases the chance that people will actually look at what you're doing. But depending on your role, it might be quite difficult to justify spending time on that. It may not be the sort of thing that lends itself to measurable, tangible outcomes that make it easier to say, well, this is what I was doing with that time, and that was a useful way to spend that time. Okay, so some suggestions for participating. The first thing to do is to find a working group that covers whatever you're interested in. The IETF has more than 100 working groups. Depending on your interests, there might be quite a number that are related to it. So an example of that is with DNS. There are 4 different working groups that are principally concerned with what might be called core DNS, and then several other working groups that are a little bit more tangential, but still mostly domain name related. Then the next step is to subscribe to the list, which allows you to get a sense of the participants, how the discussions go, and so on. Related to that is looking at the mailing list history, depending on how much you want to get into it. For myself, reading the mailing list history has been really, really useful. Because it saves you from doing things like reiterating ideas that have come before, and it also gives you a really good idea of what people's interests are and what things they might be resistant to, and so on. And along similar lines, reading the drafts and RFCs for a working group can be helpful in terms of building up your understanding of that group and the context and so on. And then from there, you can start offering feedback on documents and doing small implementations. I think in particular, the implementation part is really important because it's possible to do proofs of concepts a lot of the time, not always, but a lot of the time pretty simply, as in it doesn't take a huge amount of work to do these things. And they often turn up problems that can contribute to feedback. And people really appreciate, again, in my experience, the implementation side of things as a kind of signal of interest in the work that they're doing. It's possible that you look at all the working groups and then can't find one that covers what you want to do. And in that case, it's worth considering whether you want to start one. There's a well-established process for this. It will be easier if you have other interested volunteers. I am not sure that you could start a working group with just one person. And although many working groups are long-lived, they don't have to be. So you can set up a working group to do a very specific schedule or agenda of work. So maybe you might even have an idea of how many documents and when they'll be finished and so on. And then once that's done, the working group can just be shut down. And this happens quite a lot. And finally, just some miscellaneous general comments about participating. Back to this idea of the online archive that IETF has. You can see video recordings of sessions for the last 10 years, audio recordings for about the last 20. So there really is just a wealth of information about what the groups do, how people communicate, how people present on things, and so on. In-person participation is helpful for various reasons. I think in particular, it allows for those sorts of informal conversations around the place that can really help to fill out your picture of how a group or IETF in general works. But it is perfectly possible to participate effectively without attending in person. All of the groups, as far as I know, support remote presentations. I myself have given a number of remote presentations without that being an issue. And of course, the bulk of the work happens on the mailing lists. So yeah, in person helpful, but it's not the be all and end all. A key thing about the IETF is that your participation is as an individual, not a company representative. But the idea that your affiliation at IETF is irrelevant is not really right, in my experience. Simply as a practical matter, if you have somebody that you know speaks for some large company, saying something about some functionality that they support, then that's obviously going to have more weight than some random person who is either just an interested end user or maybe works for a much smaller, less influential company. The former is going to have more impact than the latter. That's not to say that an individual participant without a prominent affiliation can't participate and have an impact. It's, again, in my experience, very open to people coming in and trying to participate and etc. As long as they're willing to put in some work and not just asking a bunch of questions, for example. But this idea that the affiliation is irrelevant, particularly when most people who are participating in IETF are participating on their employer's time, and particularly for travel, I think maybe needs some refinement as far as the public communication is concerned, the IETFs. Maybe a very obvious point, but clear and concise writing is really important. Sometimes people have this idea that editing can be left for the RFC editor, but unsurprisingly, if a document is easy to read, then you're going to have a better chance of people reviewing and implementing it. And it also avoids back and forth with the editor if they inadvertently make changes that cause technical problems. And the last point I'd like to make is that LLM use at IETF seems to me to be quite contentious and is best avoided if possible. you can have this sort of scenario where somebody basically prompts an LLM to write a draft in Toto and then submits it. And it's almost like the expectation is that the working group will fix up all the problems. And this is not a winning strategy. So for less obvious usage for things like spelling, grammar, and so on, there's no problem at all. But in general, I'd be cautious about using products like that. And that's all. Thank you.